Okay, so let's talk about how to use Logger Pro. Now, this is meant for my physical science students, but honestly, it can be used for any of my classes that need to use Logger Pro to graph anything from set of data. So to do this, the first thing we're going to do is we're going to go to the magnifying glass up here in the top right, and we're going to type in Logger Pro. If you just type in Logger, usually it should pop up right away. Just click it, give it a little bit, and it should open. The other thing you need clearly is you need your data. So clearly, mine's on the Microsoft Word, but yours will be on paper. I am going to give you an answer to one thing, though. I'm actually going to show you where the independent variable is plotted and where the dependent variable is plotted. Okay, so my data does not represent the data used in class. This is just generic data that can be used for anything. Once Logger Pro pops up, you'll see you have an X and a Y chart. In the X chart, you need to put in your independent variable. In the X chart, the X axis is always your independent variable. This is the variable that you control. Sometimes you can manipulate. A lot of time is an independent variable, and you wonder, how can you control time, manipulate time? You can't, but what happens is things change depending on the amount of time. And so since things change depending on time, the other thing that changes is dependent, so time is the independent variable. Anyways, so what I need to do is if I look at my data, I see that I have the following. I did 6 experiments to see how force changes when I change the mass. So I'm changing the mass. I'm adding 5 kilograms every time. So 5, 10, 15, up to 30. And I wanted to see how force changed. So mass is the independent variable. It's what I controlled. And I wanted to see how force depends on the amount of mass. So force would be my dependent variable. So again, the x-axis will be my independent. So I'm going to double click the x. Even tells you double click. For the name, I'm going to put mass. Again, this is generic. It's whatever your independent variable is. In my experiment, mass is the independent variable. Don't need it. Just put mass, the units, kilograms, and done. How do I know it's kilograms? Because it says kilograms here. Okay, I'll do the same thing for the y, which is my dependent variable. So for the y, the name will be force, the units, newtons, or n. What if there are no units? Then you don't need to put units in there. It's just if there are units, you put units in. Done. And then it's literally just plug and chug numbers in. So for my data, for mass, it went 5, 10, 15, 20, 25, 30. And then for the force, let's see, 11, 20, 28. So 11, 20, 28, 44, 52, 56, 42, or 44, 52, 56. And every time you put an X and a Y number in, set of numbers in, you'll notice you get a dot here. Next, what you need to do is you need to draw the regression line. Now, the computer does that for you. Depending on the kind of graph it is, like if you click over here where it says curve fit, I can make it a proportion, linear, quadratic, etc., depending on how the variables are related. Now, I do know in this case it's going to be linear, so I can just click linear. That's one option. Or, because linear is one of the most common ones, they actually have a button right here that's linear fit, so I just push it. And it makes what's called a regression line. So notice the line does not touch every single dot. In fact, what it does is it finds the average. It finds the average between them. So here is my slope, and it gives it to me in y-intercept form, so y equals mx plus b. My slope, m, is 1.926 newtons per kilogram. FYI, that's meters per second squared. The slope does give me acceleration, but that's beside the point. And my y-intercept is 1.467. So, for example, what is this equation used for? This is a really useful equation. What it says is the following: y, my dependent variable, equals the slope, whatever the slope number may be, times my independent variable plus the y-intercept. So for example, if I go to 10, which I have here, if I put 10 in for x, so if I do 1.926 times 10 plus 1.467, I'm not going to get exactly 20 because you notice my dots here, but I'll get something pretty close to that because again, this is the regression line. So with this equation, if you plug in a number for x, if you plug in any independent variable, it will tell you what the dependent variable value should be. So I can use this data, or I can use this equation, I should say, to find y, the force, for any mass. Any mass. I just got to plug, once I know the slope and once I know the y-intercept, I can plug any number in here to get my dependent variable. Also, very important, this graph starts at 0, 0. Not every graph starts at 0, 0. Please, that's very important to understand. In fact, if I auto scale this so it's a perfect size, you'll notice it actually does not start at 0, 0. It starts at 0, 10 in this case. So please get out of the habit of always thinking every line graph has to start at 0, 0, because that's not true. But anyways, that's all you got to do. So once you have your data, put in your independent variable, put in your dependent variable, figure out the identity of your independent, identity of your dependent, the units for each if there are units, plug in your data, click the linear fit, and then you'll have your y equals mx plus b equation. You'll have your slope and you'll have your y-intercept. And then from there, and I don't know if you noticed, but you can click this button right here. This is called the examine button. And with this, I can move it around. And let's say I went to the number 20, for example, and I go up. So look down here. You notice it'll give you the x coordinate, then it'll give you a y coordinate. It's not there right now, but it will be. There it is. So as I go across, notice the x number changes, not the y. The y kind of a little bit because my hand is going up and down a little bit. Now the x should stay the same and the y changes. So the goal is to get this crosshair right on the slope, right on the line. And so at 20, even though my experiment said 44, it's supposed to be closer to 40, which in realistic terms, that really is what it probably should be if my data was accurate. So that's how you would find what your dependent variable should be based on whatever the independent variable is. And that's it.